Hello and welcome to the home version of Econometrics. I'm your host, John Harvey. We'll be using this textbook that I set down somewhere and now can't find. Here it is. Using Econometrics, a practical guide, however you pronounce that. I've been using this book, not this same one, but one by that author, since 1988. And it is by far my favorite book. The practical guide part, he takes very seriously. You will find that there are not a bunch of proofs and so forth like I had when I took econometrics, but instead he opts for the idea that if I can give you an intuitive understanding of what's going on, you'll remember that. But 5 years from now, you're not going to remember how X times Y equaled Z or whatever. So that's going to be the attitude in this class in general. I'm going to show you some proofs, but in general, I want you to try to think about how the logic underlying the process works, because that's what you're going to remember, right? That's what you're actually going to carry with you. And speaking of which, as I probably said in the introductory video, because this is actually for chapter 1, speaking of which, had a guy email me once. While I was teaching this, he was one of our alums, and he said, "Man, I didn't take econometrics. Is there something I can do to learn it now? Is there a book I can read or something?" It's like, well, I guess you could, but it's not going to be real easy. And oh my God, there are people who have graduated from TCU that wish they had taken this class. So it has a bad reputation, I think, because I believe people are scared of the idea. But A, it's not that bad if you keep up with the homework, and B, you can actually use it after you graduate directly, all right? Make sure you highlight it on your CV, on your resume. All right, but anyway, this video is not supposed to be about the introduction to the class. It's supposed to be the actual first lectures. I have my lecture notes here, and I'm going to do chapter 1 in one video. And then I'll see how the others go, whether I do it in 1 or 2. By the way, I got to show you this. Oh, I left my phone on. The little flashlight function. I was trying to get the camera set up right. Okay, you know that joke about some old professor having lecture notes from 30 years ago? I'm that professor. I did at some point Xerox them, copy them so that they weren't on the same yellow paper they were from the summer of 1988. But I am that guy because it's a math class, all right? And the basics, as far as we go into things here, has changed very little since 1988. There's going to be a couple of new things I do. At the end of the semester, a couple of things I substitute, but the core of it is still the same as it was in 1988. Okay, what is econometrics? I don't know, but fortunately, I have a way of finding out, and that is looking at my notes. And apparently, econometrics simply means economic measurement. Let me check the... Okay, and here's the deal with this screen right here, with this whiteboard. It wants to fall forward, so I've got a couple of weights down here. I'm trying to slide it forward a little bit so it's up against those. There, okay, all right, so hopefully it will not fall on me. Now, economic measurement. Okay, I mean, that's what it says in the textbook. I don't know if that's all that useful, knowing what it means, economic measurement, but there you have it. But I do like what he says in the first chapter. There are 3 main uses of econometrics. One is description of reality. Description of reality. By the way, it came with a whole bunch of PowerPoints, the book did. And I just don't like PowerPoints that much. They're very convenient for me. I don't think they're very convenient for you. I think you follow along better if I write it out on the board. Let me talk about each of these in just a second. Description of reality, hypothesis testing, and third, forecasting. Okay, so once again, the 3 uses of econometrics. Now, this one is just like, okay, he has an example here, or did I make up my own example? I think I made up my own example. The first one is, okay, I know consumption is a function of the price of the good, of the price of substitute goods, of the price of complement goods, of income, and so forth, but what are the exact relationships? Like when the price goes up by $1, what does the quantity demanded go down by? You know, exactly. Or I shouldn't say exactly, because we're not going to really ever know that for sure. But, you know, about how much is the quantity demanded going to go down? And so that's one of the things you can do, is you can use this to, hey, we'll plug all the data in, and I'll give you a basic idea how it works in just a second. We can plug all the data in, and then we'll see, you know, how much does quantity demanded fall when our competitor lowers their price by $1 a unit. And so people substitute over to their good or service. Now, we don't really use it for this too much, though. This is going to be like the entire course. All right, the entire course is going to be hypothesis testing. For example, in the one I just gave, let me get an eraser here. This is a lovely TCU eraser from Schollmeyer. Oh, that's upside down. From Schollmeyer Arena. Very lovely. And let me write that consumption equation up here that I just mentioned. Okay, quantity demanded is a function of price of substitutes, price of complements, and let's say disposable income, all right, disposable income. The income you have after taxes. Now, you may recall from earlier economics classes that while we're going to be pretty sure that the relationship between price of this good or service and the quantity demanded is going to be negative, the relationship between the price of substitutes and the quantity demanded of this good is going to be positive. If the price of a substitute goes up, we're going to buy more of this. If this is butter and this is margarine, very common economics class example, if the price of margarine goes up, then the quantity demanded of butter will probably go up. What about complements, though? What about toast? I don't think you can actually buy toast, but that if something that you use with butter, its price goes up, well, then that's going to be a negative. But this could be positive or negative as disposable income goes up, because if it's something that you buy because you don't have much money, like when you're in college, like for example, I can picture it, macaroni and cheese. When your income goes down, you might buy more macaroni and cheese. So this might be negative. Income goes up, you buy less. Income goes down, you buy more. Or it could be steak. If it's steak, when income goes up, you buy more. When income goes down, you buy less, in which case it would be a positive sign. Let me write both of those up here. Let's see here. I don't know if you can read that, but that's okay. I'm just going to tell you what it says. Negative. I'm sorry, inferior. All right. It would have a negative sign, a negative relationship, I should say, at this point, if it's an inferior good like macaroni and cheese. I'm going to turn the fan on because it actually turns out to be a little warm in here. Let's see here. Here we go. An inferior good. If it's steak, however, it's going to be probably a plus sign, a normal good. Normal goods, their quantity demanded goes up as your income goes up. Okay, so now back to hypothesis testing, all right? That second use of econometrics. What if you're not sure? What if you don't know whether or not this is a normal good or a inferior good? Well, then you run this regression, you estimate this relationship with data, and then you look at the sign. And you find out, Now, something I want to emphasize here is you never prove something with econometrics. You supported your argument. So you say, it turned out to be a plus sign. Well, this supports the argument that it's actually a normal good. Or if you had a negative sign when you ran the regression, when you did the estimation, you say, this supports the argument that it's an inferior good. All right. So that's by far the most common. And let's see, do I bring that up right now? Yes. And you have to be careful here. Just because we get a negative sign doesn't mean it's statistically significant negative sign. That's going to be a big deal in chapter 5? I can't remember now. I think that's right. Sorry, I just finished lunch and this is my after lunch cup of tea. Because my mother grew up in London and that's what we drink in my house. Now let's see. Just because it is comes out negative when you estimate this relationship. And this is all introductory stuff here. I mean, I just kind of give you a basic idea. I'm not expecting you to learn something specific from this, but just to kind of get you a feel for what we're going to be doing. But you've run this relationship, you did come up with a negative sign, but is it statistically significant? Now, what I mean by that is, let's say you run a casino for the mob, all right? And you suspect somebody at one of the gambling tables to be cheating. So you get a couple of your muscle, and they drag this person up to your office, and you say, I think you're cheating. I think you're using a coin, yes, some sort of crappy casino game where you flip a coin. You're using a coin that is unfairly weighted towards heads, all right? Unfairly weighted to heads, all right? This person keeps winning because they keep saying, I think it's going to be heads, and they flip it and it turns out to be heads. And you think, that person's winning way too often, we're losing money to this person, maybe we should kill him. And so you drag this person up to your office, or you don't, you have people that do this sort of thing for you, and you say, hey, Bob, started to use an ethnic name for the mafioso, but I thought, well, no, let's not do that, because you're on tape, John. Hey, Bob, flip that coin 100 times and write down how many times it comes up heads. And remember, we are suspecting that it is unfairly weighted towards heads. Right? Flip that coin 100 times, see what you get. What if you got 51 heads and 49 tails? So you got more heads than tails. Would you have this person dragged off to the river and put in I don't know if you watch enough mobster movies or not, cement overcoat and then put him in the bottom of the river? Would you have this person killed over 51 to 49? Maybe you would. Maybe you just kind of a jerk. But statistically speaking, this could be a fairly weighted coin. This is not really that much off of 50-50, all right? So this is not indicating that it's an unfairly weighted coin. Yes, we did get more heads than tails. Yes, we did get a negative sign, for example. But whether or not it's statistically significant is a second question, all right? The first one is, did you get the sign you expected? The second one is it statistically significant? What if you had got instead, how far down does the camera go? Okay, good. 99 and 1. Okay, well, this person needs to start running because this is clearly statistically significant. This is going to be, yeah, your coin's unfairly weighted towards heads, all right? Now, where do we draw the line? That's chapter 5. All right, chapter 5 will start talking about, well, at what point would you say, okay, that's enough to convince me that it is statistically significant? All right, so the most of what we're going to do with econometrics is that second item, hypothesis testing. And that's going to involve estimating a relationship and very often looking at almost all the time, looking at the sign and then trying to decide, okay, it came out negative just as I expected, for example, but now I need to check the statistical significance. And that's most of what we're going to do. Okay, let's see here. Yeah, I don't need to tell you that. All right. Oh, then the third one was forecasting. And you can probably take a class on astrology somewhere else that'll teach you about we're in the middle of the COVID right now, and some guy that works at some investment company, I can't remember now, in New York, emailed me and said, what do you think inflation is going to do? And I said, well, I think it's going to fall. The CPI is going to fall. And he said, well, I've got a buddy that's a econ degree from Harvard, says it's going to go up. And I said, it's wrong. Because yes, the price of food is going to go up, but the price of gas is so low that it's going to swamp the price of food. Guess what the Bureau of Labor Statistics just released this morning? It literally had that in the headline. So sometimes forecasting works. When it does, you stop and never forecast ever again because it is extremely difficult because there are way too many variables. All right, so we're not really going to do forecasting in here. There is a chapter in the book if you want to look at that later, but otherwise it's not really something we really do very often in economics. Okay, so now I want to show you what the regression equations will look like. See, and this is the problem here. When I erase this, it pushes it back against this blinds. I wanted to leave the blinds open, but there was just no way it was going to be too much of a contrast. Let's see if I got it back in the right spot. Pretty much so. Okay, so this is what our typical single equation linear regression is going to look like, all right? Let's see. I guess I'll use the black pen. Y equals beta sub 0 plus beta sub 1 times x, all right? What we estimate is usually going to look like that. This is what we're trying to explain, like quantity demanded of some good or service. This is the, well, I'll show you what that is in a second. And this is the variable over here. X is going to be an independent variable. This is the dependent. Independent coefficients or parameters. Oops, sorry. So, the example I like to use in econometrics over and over and over, because I know that all of you have a great familiarity with it, is grade on the test, hours of study. All right? So, we're trying to see, I wonder what determines somebody's grade on the test. I'll bet it's how many hours they study. All right? So, let's say you collected these data, and again, we won't get to the actual how you estimate the equation for just a little bit, but what you do is you put the data in the computer, and the computer spits out for you beta sub 0 and beta sub 1. All right, that's what it's going to do for you. And you can have extra determinants as well, but we won't cover that quite yet. Let's just do one determinant at a time. So this variable, we're assuming, is determining this variable. And again, you plug the numbers in for the grades, you plug the numbers in for how many hours each student studied, and the computer tells you, oh, I think that beta sub 0 would be so-and-so, and I think beta sub 1 would be so-and-so. Now, what does that look like? Let's see. I think I'll just show you this first. This is straight from the book. And by the way, the book is very well written. I'm very pleased with the book. It's why I've stuck with it for over 30 years. This is a graphical representation of the coefficients of the regression line. And so you have y there on the vertical axis and x on the horizontal. And let me do this. Let me erase this. And yeah. Okay. Let me erase this. This was my whiteboard in my office when our office was stuck in a trailer for about 10 years, which was well before you got to TCU. When they were just going to destroy the trailer, so they said, well, if anybody that wants their whiteboard can have it. I was like, yes. So, all right, let's see here. How was the glare? I guess that's okay. Yeah. All right, I'm not going to write, well, I guess I will. All right. Y equals beta sub 0 plus beta sub 1 x. I'm just going to write underneath here grade and hours, so that you have a better grasp of what this is by putting on their specific relationship there. And something that I hope you are very familiar with. All right, so what econometrics does for you is once you give it all the data, sorry, I got tangled up in my microphone cord here. Once you give it all the data, it's going to give you beta sub 0 and beta sub 1. What's beta sub 0? Well, it's going to be the intercept, all right? So, for example, right here. And beta sub 1 is going to be the slope of the line. Beta sub 1 is the slope, right? And, oh, let me write the equation of the line out over here. Y equals beta sub 0 plus beta sub 1 x. Now notice I drew a positively sloped line. I'm assuming that the relationship between hours of study and grade is a positive one. And I also drew it as a straight line. It might not be a straight line. It might be that after you've studied for 5 hours, the additional benefit of studying for 1 more hour isn't the same as it was studying from 1 to 2 hours. So you have like sort of a curve one way or the other, all right? But we'll cover that in chapter 7 or so, I believe. So it doesn't have to be a straight line. I also assumed a positive intercept. There's no reason it has to be, all right? But so this is what you've got then. what you have is, let's say that the computer estimated this relationship for you. And so you're like, oh, okay, all right. So, hey, I got some kid that studied for 6 hours. Can you see the orange okay? Yeah, 6 hours. Then he hasn't taken the test yet, but I wonder what grade they'll get. I bet it'll be right about whatever this number is right here. So 6 hours is going to be equal to beta sub 0 plus 6 times the slope of the line. All right. I don't know if you remember that from algebra or not, but I'm about to go over it here in a second. I guess let me make up an equation. I believe I've already done that for you here in my notes. What did I do? 50 times 4. Okay, so what I did, I made up an equation. Grade equals 50 plus 0.4, just 4. 4 times hours, all right? Back up a little bit. I wonder if it even needs this light. Maybe I'll put that over there. Okay, that's better. What I did was here, I made up an equation. Grade is equal to 50 plus 4 times hours. So I don't know that our graph here is really set up to, there we go, that's better. Set up to, it's going to look like it's a little off on the scale. But if this kid studied for 6 hours, 24, 6 times 4, plus 50, is a 74. Like, oh, the kid will make a 74. You know, based on my research, based on my study, my regression analysis said that your grade tends to be equal to 50 plus 4 times the number of hours you study. All right, so that's what this is all about. This is so here's your slope. There's your beta sub 1, and there's your beta sub 0. Oops, sorry. That's among the worst zeros ever written in the history of econometrics. And there's your beta sub 0. So, again, and I know I'm going over and over and over this, but you know, you get this early stuff down and it's going to make the rest of it much easier. What we're going to be doing for the rest of the semester is plugging data in, finding data on people's grades, not just that obviously, and hours of study, and then punching a couple of keys on the computer and asking it, you know, well, get beta sub 0 and beta sub 1, and that's what it'll do. And if in this case beta sub 0 and beta sub 1 is 50 and 4, then what we have over here is 6 is going to give you over here 50 plus 4 times 6. That y right there is going to be 50, the intercept. You're already 50 up, all right? And maybe this is a true-false exam, all right? Maybe this is a true-false test where a monkey, you know, where just by chance you'd get a 50, all right? So you know, that might be a way you could justify, what if it's a multiple choice test with 4 choices? Well, then maybe our intercept ends up being 25. We don't know that for sure. We don't know that, but that's a basic idea, one way to think about the intercept over here. So you know, really, a monkey's going to get a 50. And then if you also study 6 hours, you could beat that monkey on the test, all right? You could end up with a 74. That the slope of the line here, which of course, as you know from high school, delta y and delta x, so delta y over delta x, how much does y change when x changes, is what beta sub 1 means. When it's 4, when x goes up by 1, y changes by 4. All right? When x goes up by 1, y changes by 4. So the question that you're asking with beta sub 1 is, how much is y going to change for a 1 unit change in x? And it's just the slope of the line. All right, so again, the book is very well written. And he goes over this early on. He's like, look, this is what we're going to be doing. We're going to be coming up with these lines. You plug the data in. The computer spits out the beta sub 0 and beta sub 1. And let's see. Let me look at my old notes here. I've got a new set of notes and an old set of notes, and I want to make sure I covered everything I wanted to up to this point. I do want to mention that. Yeah, I better mention that. Okay. I already said it doesn't prove anything, right? I already said, you know, you're not proving anything with econometrics. You're just supporting an argument. So be careful about that. And also, it's not showing causation. It's only showing correlation. All right. Now, strictly speaking, we can probably assume, since this happens before this happens, since studying happens before you take the test, probably this is causing that. But the technique itself does not show that. Because in fact, you could switch places. You could put hours over here and grade over there, and the computer doesn't know whether or not, which one happened when. The computer's going to think, the grade on the test determines hours. Okay, all right, so I'll run it like that. So it doesn't prove causation. It only shows correlation. And something else I want to tell you, and I guess I'll cover this too when I talk about how to use the software, is that think of the computer as like a puppy. It so wants to please you. If you put in a regression that says grade is determined by someone's height, it's going to say, okay, I'm going to do my best, master, to figure out what the relationship is. It's not going to question what you put in there. It's going to assume you know what you're doing, all right? And that's going to be very important later when we talk about choosing variables to put into the equation, is that the computer's not going to make any choices for you. You have to figure that out for yourself. And by the time you put it in the computer assumes you know what you're doing, which could sometimes be a very bad assumption, couldn't it? Let's see. All right, so I think I'm ready to move on to the next topic here. And this light is still bothering me some. I guess that'll work, all right. All right, let me erase this. Boy, oh boy. To teach this class online in the summer because of the COVID, I had to take an online training course that took me hours, 2 days to complete. And then this Friday, I'm doing this on, what is the date today? May 11th or something like that. This Friday, I have another training session to take that is one that I have to, May 12th, the one that I have to watch online. And I got to tell you this, it's been a lot of work, but I'm kind of proud that TCU is doing this. The TCU is like, look, we're not just going to let you make up how you do online classes because it's very, very different. And it's a lot of work. You've got to pretty much do everything up front and have it all set to go before the semester starts. So I'm really happy that it's been a pain in the neck, but I understand why. That we need to do this if we're going to do these classes properly. All right, let's see. Back to our topic at hand here. I've gone through these 2 pages. Oh, yeah. Now I got to tell you about, okay, now it starts getting a little weird, all right? The stochastic error term. Let me write that up here on the board. Let's see, I'll use blue. That bothers me right there. It's scratched, so I almost never write right. I end up just using this little portion over here. Anyway, hey, that's my problem, not yours. Oops, I just misspelled stochastic already. Stochastic. Oh, John. Stochastic error term. I know how to spell it. I was just too excited to talk about it. Okay, here's the deal. Let's go back to that grade and hours thing. I told you I'm going to go back to that all semester long because it's just so familiar to you. It doesn't depend on you having taken a different economics course than everybody else in class or something like that. All right. This is your theoretical relationship. This is what you think is true. All right. And even if you're absolutely right, even if you're dead on, even if that absolutely is, one day when you die, you go to God and you say, I don't know if you can tell me this or not, if it's something you keep to yourself, but I've always wondered what the true relationship is between hours of study and grade. And God says, well, come on over here, and gets a whiteboard out and so forth. I said, this is the actual relationship. It turns out to actually be 49 plus 3.7, the sort of true relationship. But God, we assume, is going to also add this variable at the end. And that is an epsilon. Let me see where I am in my notes here. Yeah, an epsilon. That is the stochastic error term. Because what it says is, yeah, but it's not like exactly 1-to-1, all right? It's not like an absolutely mathematically deterministic relationship. You don't always get exactly 49 plus whatever I said, 3.7 times hours of study. Give or take. within a certain range, all right? And so, I don't know, I've always thought of this as kind of a philosophical assumption, that what we're saying here is that even if we knew the true relationship, which we don't, which is why we're estimating it, even if we knew the true relationship, we still have to say, for the most part, this is the way it works, all right? But there's going to be some variation. Now, what it says in the book, and this has always bothered me, and so I don't explain it this way. Well, I'll mention it just because it says it in the book. Here it is, okay. Why the stochastic error term, and this is from the book. There may be minor independent variables we have omitted. All right, well, then we probably should have included them. All right. An incorrect functional form. Remember I told you it might not be a straight line, it might be curved one way or the other? Well, then we should have estimated it differently. Or measurement error. Okay, that's a problem. All right, the one we can't get around. You know how much we in economics depend on what somebody else has calculated. If we were on an ag econ campus, for example, or just agricultural campus, then we would be creating our data ourselves. We would be like planting a field and putting this fertilizer in, and planting a field and putting this fertilizer in, and then we would collect those data. We would be creating the data that we need, and it would therefore be especially useful and especially appropriate to us. We just got to take whatever the hell the government calculated. You know, most of the time we're like, okay, we'll use this GDP figure here, and they're approximations. All right, so measurement error is certainly a possibility. That one I toss in with. But perhaps more importantly, I added that part. We are assuming that real world relationships simply have random elements. All right. Now, whether they do or not, we don't know. Turns out not to be important for us in this class to know that for sure. But again, the idea is that even the true relationship has some random elements to it. All right. Let's see. Expanding the notation. All right. Here we go. I was going to try to make this not too terribly long. Well, I've been 30 minutes. I'm wondering if I should stop right here and start another one. Let's do that. Let's break it into a half an hour chunk. All right, so there's your first half hour. I'm going to stop it and then turn it right back on again.